Is a business relationship between a provider of funds, resources and services called the
अभी ना जाओ छोड़कर कि दिल अभी भरा नहीं अभी अभी तो आई हो अभी अभी तो
Good evening, everyone. I, Dr. Nilakshi Jain, on behalf of Shah and Anchor Kachi Engineering College, Mumbai, India, welcomes you all in a hybrid webinar series, Innovative and Emerging Technology in the Field of Research. This international webinar series is hosted by SAKEC with 25 plus national and international collaborators. And special mention of our international collaborators, University of North America. Now, I would like to take this opportunity to invite the one who gives direction to every student and faculties in the college. He has been our guiding light and has always encouraged us to give our best. He makes the task of running the college look so smooth as he silently manages all the tasks. He is none other than Dr. Bhavesh Patel, Principal SAKEC. Sir, I request you to inaugurate the session with your kind words. Guys, he is joining again. I'll request my co-host that just to play the North America University video again, please. Okay, I think we will be starting with the presentation. Sir will be joining in some time. So, guys, it's a great pleasure for me to introduce our speaker, who is going to talk about the new world of artificial intelligence. This is a subject in which we should be, deeply interested because it is a hot pick now in the world, and we are really privileged that this topic is going to deliver by a person who is a chief architect at US Federal CTO at IBM. Our speaker, he is specialized in healthcare solution, management consulting, cyber security, cloud computing, artificial intelligence, digital transformation, and organizational design. Ladies and gentlemen, please welcome Mr. Ramesh Menon, sir. And this is the first time when we are hosting two big divas at the same time on a single platform. I am very excited to introduce our co-speaker for today's evening, Mr. Srikanth. He is a startup specialist, CEO Managing Director at Blue Eye Soft Information Technology Services, US. He's going to show us some emerging technology trends and applied research. He has co-created software technology and advanced research in AI to help doctors to diagnose and treat patients. I am very sure this 1 hour session will be the best techie session for all of us. So before hand over to our speaker, I have few announcements for my audience. All participants, if you have any query in between session, please write in QA box. Frequently asked questions will be asked at the end of the session, and also at the end, feedback link will be provided in the chat box. Participant will receive e-certificates based on info provided in the feedback form. Hence, please mention your name and email ID correctly in the feedback form. Now, I'll request my honorable speakers, please take over and start the session. Thank you, sir. Please, Srikanth sir and Ramesh sir, start the session.
Hello all, I hope you can hear me.
Yes, sir, just wait. Yes, sir, you can start.
And can you see my screen?
Yes, sir.
Perfect. Hello everyone, thank you Dr. Jain. Glad to be with you all today. Just to give a quick level set what I'll be covering, I'll probably spend around 25, maybe 30 minutes to talk broadly on three topics. One, the current state of the world, the new normal with COVID, what's happening, what are we doing with that, how do we get back to work? And then I'll cover a little bit on AI and quantum, what's happening in that space. And then I'll give it over to Srikanth, who will show you an exciting application of AI where we can auto detect COVID from lung x-rays, right? That will be a live demo he'll show us. So I want to make sure I cover enough topics at the same time, not bore you too much with PowerPoint. And maybe if time permits, I can try to show you an adversarial AI attack, how it gets done. Okay, let me see how it goes. So I know we are all living in a very interesting times. I guess all your classes are online. I'm not sure if you're all back to your schools, but it is tough. I was talking to one of my friend who has a school in India yesterday, and they were all worried that how do you open the school? What does it mean? And there's an economic impact for keeping things shutting down, and there is a learning experience that all the students are missing, right? You probably miss your friends and school, and probably sitting at home and watching videos and YouTube. You can only do so much. So it's an interesting part, right? So my involvement with COVID was probably early January, where I started tracking this once I heard it in China and was started collaborating with my research scientist in my computational genomics division in IBM research as he was doing some drug discovery and antibody testing for the COVID. And we were just doing just like we do research, right? We never expected this to become such a big global phenomenon in the first place. And we had a head start and we were prepared as an organization. So before COVID, we had probably 50% people working from home. And by March, you can see that, especially in India, 99.5% people in India are working from home. I mean, that's a very incredible transition for any company, especially for us with 400,000 employees in 170 countries. I mean, IBM did a very smooth transition. For me personally, it is less of a change. I mean, I'm used to working, traveling around the world, so it was less of a change for me. But for people who come to office, it's probably slightly different. But we had the underlying platforms and technology to scale and move the people into the new business model, right? So that's happening. And we started creating some software on how do you return back to work using our AI effectively to support our customers. So I think it's still going on. I don't think we are totally done yet, but yeah, at least in the US, we are in phase 2 of opening. I know my Starbucks is open. I can go inside and get a coffee. I don't think I can sit down, and there's drive-through. So I believe as of last week, and even some restaurants are open where they reduce the number of people with some social distancing and how many people can get into the restaurant. But slowly things are opening up. And I would say it's all about risk management, right? I mean, there are two sides of this coin. We have to learn to adapt, evolve, and manage the risk. I mean, there is never a zero risk game. I mean, as probably most of you know, it's similar to the cybersecurity concept, right? We have to understand, manage, and evolve. That's where it is as a world, and understand the underlying public health capacity on potential scenarios that could happen and be prepared for it. That being said, where I was focused on and where IBM is focused on, I'm on the IBM COVID task force trying to roll this out across our global companies and customer base. First and most important for us was our safety of our employees and customers, and then was collaborating with our global partners on research. How do we accelerate research? So this is a time where all the scientists and engineers have to come in and provide our brain power to solve these kind of global problems. I mean, this is not any one person can do it by themselves. There's a lot of collaboration required among countries, nations, universities, public-private partnership, and see how we can all support and evolve, right? So first thing what happened, maybe I think it was February, a university reached out to me telling they need access to our supercomputer. And so our supercomputer is actually owned by US government, even though IBM created it, it's owned by the US government. So I reached out to the director of that research lab telling, hey, this university is working on a drug for COVID. Can we get access? And I made the call like 3 o'clock in the afternoon, and next day morning, 8 o'clock, it was ready. So that was very impressive, that working with a government agency, such a quick turnaround. That was very, very useful. And my executive vice president, Dr. John Kelly, told me, hey, Ramesh, why don't we just make it a consortium and bring in more people? And suddenly we have a consortium where, I mean, MIT, Rensselaer, Amazon, Microsoft, we all pooled in our resources, and we have almost 400 petaflops of compute capacity available to anybody in the world who wants to do research on COVID and create solutions. And I'm pleased to say that we have almost 60 projects going on right now across different domains. Most of them are drug discovery, antibody discovery, things like that. But there are other things also where you can speed up the development of new drugs and other genomics platforms. And it is available to you. I think you guys can look at that link. I put it on the slide, and you can submit your project proposal. Now, this project proposal will be reviewed at a fairly high level. There's a team from White House who will be looking at it. And my executive sponsor, Dr. Dario Gill, who heads IBM Research, is actually on that team. So we are involved at a global level in all these research happening, what gets approved, and all those things to genuinely make sure that we are allocating resources to the right cause, right, at this point. And I think it's doing very well. As of last week, I believe there are 6 clinical trials going on, and 2 of them seem to be very positive. There was no side effects on any human beings on the clinical trials that was going on. So I think we should hopefully see some vaccine by end of the year is my guess, although I don't control that process. At least in the US, the process is very rigorous on how drug discovery gets done. There's clinical trial, phase 1, phase 2, phase 3. I mean, generally they do it on animals, then human clinical trials. So we are in phase 2 of human clinical trials right now. So that's a positive sign for all of us as a humanity, and hopefully whatever we are facing is a short-term thing, and we'll all be back to our regular works very soon. So this was the computer we used. I mean, it's used by the Department of Energy in the US that IBM created. It's an expensive computer. It's around, I don't know, $200, $300 million and 200 petaflops of capacity. But this is the underlying machine that's being used for all these kind of drug discoveries. The another focus area where we are looking is how can we collaborate and do the research capabilities, right? That's one area to do. Now let me see. Dr. Jain is saying share your desktop. So let me see, something's wrong here. Okay, maybe let me try something else. So you're not able to see my screen? Is that what you're saying?
Yes, sir. I mean, we can see you completely, but your presentation we are not able to see.
Okay,
Just share, sir. Just share the desktop. That's it, sir.
Share.
Yeah.
Okay.
Just share it, sir.
How about now? Can you see my PowerPoint? No? Share. How about now?
Yes, sir.
You can see it?
Yes, sir.
Okay, let me go back to this one screen which I was talking about, right? The the HPC consortium. So if you want to submit projects, yeah, please go ahead and submit your proposals. I'll share the charts after the call. You can post it. I'll share it. There's nothing. It's a normal thing. I do teach at Johns Hopkins University in the computer science class, so I do something similar. So I just stuck with the same thing. So can you still see my screen? I just went to full screen. I think that's where you lost me.
Yes, sir. Yes, sir. That's fantastic now.
Perfect. Thank you. Yeah, so what's happening is we focused on certain key areas, and primarily we were focusing on 7 key areas on what we can do, right? There are, let me skip some things, right? I don't want to go over all these in details, but most important thing where we see is how do you virtually engage with people? How do you work remotely? And those are the basic things that is coming up. And something that is new. So I think people know to work remotely. People know to provide virtual capabilities. We can add AI-based bots to help human beings. Those are all fine. Something new that's happening is risk management. How do you manage operational risk? And I think that's where things like contact tracing, proximity tracing will be important to reduce and manage the spread of infection, right? Because we are still in COVID. I mean, nothing really changed except that we as a society and humanity are taking greater risk and managing it effectively, right? So I think it is very important to at least have manual contact tracing where you have a piece of paper on what date, what time, who you met. And it becomes very tough sometimes if you're taking metro and with 500 other people, it's almost impossible to know who you came in touch with, right? Those are tough things to handle. And I believe Government of India has some app, right, which is used for contact tracing. So in US, it's still not fully there. We have capabilities. I had a call with the National Health System of UK on Friday. We are looking, at least within offices, right? When we start opening an office, what kind of controls do we need? How do we handle that? So there are a couple of things that we're doing. We are planning to put thermal cameras at the entrance of the building that will measure the temperature. Not that it is a solution, but at least in schools and colleges, you can make sure that you're not bringing a sick child to the classroom and they can be sent home to ensure that other people are not infected. Same with hospitals, right? If there is a staff who is sick, I mean, you're better off staying home than bringing that infection to the hospital, because there are many people with weak immune systems and we have to ensure the safety. So we are many employers are doing it. So that's one area. Second is the automated and manual contact tracing with technologies like Bluetooth and ultrasound. That is also coming along fairly well. So IBM's 4 main areas were based on 7 pillars of our COVID response, right? What can we do? Obviously, most important is the resiliency and business continuity plans. How do you ensure the business continuity? And right now, I would assume most large companies have a business continuity plan. Everything is going on as usual with very minimal impact. At least in US, that's what I can tell. I mean, yes, restaurants and malls and those kind of things have been slightly impacted. But on the technology side, I mean, universities and other things are kind of pretty much going on with little less impact. I think the impact to IT was it's still less. I mean, there is the human aspect of it, but the technology infrastructure is fairly robust and things are moving on. In fact, we are working a lot more hours. I can tell you that. I mean, compared to 6 months back, I'm working a lot more hours than what I used to work 6 months back. We are also scaling the digital platform capabilities, right? So cloud is becoming very integral to every single business, whether it is banks, hospitals, educational institutions. I mean, how do you leverage cloud as a digital platform and create new platform-based business models? And that is very important for companies who have it. It is good. For companies who don't have it, I think it is time to start paying attention to it. I mean, for example, I'm not sure if you have online classroom, but it might be a useful thing. So you can have a blended education model. So when I teach at Johns Hopkins University in Baltimore, some classes are online, some classes are in person, and they figure out what can be online, what can be remote. And it also gives flexibility to students, right? Certain subjects, they come to college, certain subjects they do online, and it depends on the professor who is taking the class and learning outcome and impact. So these blended learning models are evolving, and that will probably continue going on. But although I agree with you that there is no replacement for in-person human-to-human contact, I mean, that collaboration and personal touch is always different, but it's a augmented model. I'm not saying it's a total replacement. So it's a blended model that it evolved. Second area is the evolution of AI-based capabilities, whether it's for customer service. So we already had this Watson chatbot in help desk. Most of the large banks were using it, like JP Morgan Chase, and it's not like typical IVR where you make a call and the machine asks press 1, press 2. You can just talk. It understands natural language fairly well. We can extract the understand what somebody is being saying. And what we really figured out is the interaction between a human and a machine. So a machine would know when to hand the call to a human, and human would know when to hand the call to a machine. I think human handing the call to machine is easy, but when the machine would know to handle to human is a very interesting learning algorithm, right? So those kind of things are coming very well, and that partnership between human and machines is growing very fast. So that's a good one, and you can try it out. All these capabilities and APIs are available. You could use it in your college projects or in your own applications, right? So going back to COVID, I mean, right now we are focusing on the workforce assurance, return to work, contact tracing. How do we digitize and augment the workflow? There's some network readiness, the bandwidth, and other areas depending on what you're trying to do, right? So return to work was an interesting thing, right? It was done in probably 4 weeks, 5 weeks. There's one application for the employer or the university in this case, in your case, and the students would have a mobile app and where they can do your self-reporting capability. And this is based on the data from the government. So for example, if you look at the Weather Channel app, right, the Weather Channel application, which is the weather company is owned by IBM, and we have 80 million users in the US. I don't know in India, but there should be a real-time COVID tracker. I just looked at it before joining this call, and I believe India has around 2.5 million cases, roughly 250,000. Yeah, and so there are information available. You can ask questions. There's this chatbot integrated into that application. You can ask some questions, and it will give the answer. So those kind of capabilities will continue to evolve, right? And this is something where most of us are planning to do in phase 2 of opening. How do we manage the risk and provide actionable guidance? So let me give you a very simple example. Maybe I go to office, I take elevator number 2, go up to 3rd floor, right? And in my elevator, I had a colleague, John, who was with me. And if I am positive, hopefully, I mean, John should also quarantine. But there's a different problem. After we both go to office, maybe after 1 hour, some lady, Nita, comes out from 2nd floor or 6th floor and takes the elevator down. Now that person is also exposed because of the elevator. The contact is not just between human to human. It's human to anything else they touch. It's between the virus and human. And that is a very interesting aspect to learn and evolve. So we are also tracking those data, like which elevator, where they are. So location is very important. So we can send automatic notification to these people telling that please stay quarantined. You may have been exposed because you took this elevator 3. So that needs very sophisticated science, right? And that's currently what we're working on. And it's based on edge weighting problems and how we are using this for contact tracing, right? So if you see on the bottom part, like if there's an infected person, so Michael is my team member, he's working on this thing. So he's there on the bottom where he used a graph database to visualize so there's 2 parts. There is the contact and there is proximity. So we track both. And these kind of information will be helpful in managing and containing the spread of infection, the R naught, right? R naught is the metrics by which you understand how the infection is being spread. Now, the fever detection is relatively simple. I mean, this is a good college project. I think most of you can do it. Just get a small thermal camera and create a Node-RED application, and you can deploy it as a container application on any cloud, right? That's simple. Now, what we have done is IBM created something called Edge AI Application Manager, where you can take any application in any cloud and deploy it onto the edge. What do you mean by edge? On a train, on a bus, inside a small camp on a mountain, you're going for a hiking. So it could be the workload. And this is an example of a connected sensor, but it could be anything, right? It could be weather, it could be whatever your application is, how do you take that workload and move it to a specific geographical location where you don't have internet connectivity? So these kind of things are also evolving. So what IBM has done with our hybrid multi-cloud platform is you create your application once. Typically right now, most people are building a containerized application with Docker and Kubernetes. And once your application is built, you can deploy it anywhere, whether it's Amazon Cloud or Microsoft Cloud or Google. I mean, so we have a standard multi-cloud management software which will ensure that your workload can be placed anywhere without it is transparent to you. You build your app, deploy it anywhere, including to the edge. So you can say, hey, I have a team going on a hiking to somewhere in maybe Himalayas, right? You're going on hiking. How can that team get access to some of these applications? They could have a small Raspberry Pi or some small form factor device where this app can be running and it will do the sensing on the edge kind of capabilities, right? So these are evolving, but fever detection is the most common one where most hospitals are starting to deploy and some offices are starting to deploy. And we are also not collecting any information. Most of the data is there for like 2 to 3 weeks because the shelf life for the quarantine to know is last 3 weeks of data, and then all those are gone away. Nobody's storing any data. It's all anonymized. So it's fairly done in a compliant manner, especially with in UK regulations like GDPR. Now, switching back to just that's the COVID. I mean, hope all of you are safe and taking precautions, but I think we'll all get over with it. Now, coming back to technology, right? So what's IBM doing with AI? So IBM has been doing, obviously, it's an old company. We are 100-plus-year-old company, and we have lots of employees. And the good part, I'm proud to say that it's a great place for researchers and engineers to work, right? We get 10,000 patents every year, roughly. I mean, 9,500, 10,000, which is 3 times more than the second highest patent holder, I believe, is Samsung. So we do very well. We have, I don't know, 100,000 plus patents or more than that, but it's roughly 10,000 patents every year. And right from 1928, when we invented the punch card, to 1957, when Fortran was invented, to 1974, when the first relational databases was invented, right? Which is probably still being used right now with SQL Server and Oracle and all these databases, which IBM invented in 1974 from that. So it's evolving. Where we are going, in my opinion, is a convergence of bits and qubits, right? I mean, there's a whole evolutionary thing happening with quantum. I mean, that's a big thing. I mean, we have started to scale our quantum teams internally, but AI is also continuing to grow parallelly. Most of you might have seen the Jeopardy, right? The Watson system that is in the game show for questions and answers. And yeah, if you not check out on YouTube, that's a great video to watch in 2011. And it was well received. We created certain commercial offerings like Watson for Oncology and things like that. And now the most recent one that we created is a project Debater, which is few months old, maybe sometime last year, where we have teach the machine how to argue with humans, argumentation. Now, argumentation algorithm is not simple, right? So we can understand documents, extract keywords, create knowledge graphs. Those are all simple things. Natural language understanding, maybe what I'm speaking, a machine can understand. But how do you argue with me? You need to understand that there's a common sense involved here. You have to be able to summarize the information. If somebody talks for 1 hour and maybe your professor is teaching for a 1 hour class and your friend did not attend the class and he or she calls you and asks, hey, what did Dr. Jain talk in class today? And how do you tell that in like 2 minutes? Oh, it was about whatever, right? I mean, transfer learning algorithms. So how can a machine know from a 1 hour talk that this topic that is the key summary of the information? So let's say there is help desk. There are millions of thousands of calls that come into help desk. How do you summarize the themes of it? And this information is very helpful for marketing campaigns, understanding customer feedbacks, making constant improvements in real-time basis, right? If you're a travel agency providing vacations, how do you use these kind of things? Not only to basically its ability to summarize large information and engage with human beings, right? And that's a good video too. I think you should check it out on YouTube. I did put that into the link at the end. So check it out. Project Debater is a great one. We are right now basically using that for summarizing information, other things are happening with the research. So how we are using it is we are doing it to create automatic clusters. So if I have 100,000 documents, I have all the COVID cases in India, right? 250,000 cases. I can automatically create dynamic clusters based on their age and severity, what protein, what type of virus, automatically, no human being doing anything, right? That's a key part. You dynamically create clusters. How do you do clustering today? I mean, it's probably you have to do something, right? You probably create an AI. So it's a very sophisticated capability. I mean, a lot of those APIs should be available. You can play around. We do a lot of research, right? I mean, obviously, I'm not an expert in all these things. Yeah, I probably know 60, 70% of it. I mean, definitely not semiconductor biology and physical sciences, but other things, I think I'm okay. I can claim to know something, right? So, and you can ask questions in the end if you have anything around any of these things. And if I don't know the answer, I will get back to you, right? I'm not saying I'll answer everything, but depending on the time, if you, yeah, please shoot your questions and we'll make sure you get the answers. So how does AI work, right? So if I want to understand, I'm doing a face recognition or object recognition from a convolutional neural network, right? Typically, you create a TensorFlow model. So what's this? The machine is learned based on data. There's two parts in any AI. What is AI? It's training and inference, right? You train a model and use that model inside your application, which is used for inferencing. Now, what is the problem with doing that? You can train a model to train cat, and then when you use that API in your application and put it on a camera, and what if you get something else which is not a cat? There is a chance to have bias, especially if we start using it on human beings. So there is a ethical dilemma here, how we use these technologies. That's one part, the social and ethical aspects of it. Second, even from a scientific aspect, how do you ensure there is fairness and bias to these algorithms? Who is testing it? Who is certifying it? I mean, just because something works on A, there is no guarantee that this works on B or it works as intended. And so these are things that is happening. I did see in the video before joining that your college has an IEEE student chapter, I guess, right? So I'm actually a member of the IEEE standards group for algorithmic bias. It's called IEEE P7003. Yeah, I would encourage you to join, contribute. I mean, we all have to share our different perspectives if we effectively want to understand how to use all these things effectively, right? So there's multiple layers, and each layer has their hash code. So when you do retraining, you don't have to go back from the first to retrain to change the maturity of the model. So I always tell my customers two things. There are two important aspects. What is the accuracy of your model, which may be F score or something, and what is the validity of your inference? How do you know it is valid? It works. Just because it works, is that accurate? Is it right, contextually aware? So those are the things you have to pay attention. And I would recommend keeping the team that creates the model separate from the team that does the development. Maybe it's probably going to be tough in a college setting to do that, but in real life situation, the data scientists create the model and the developers use those models and create the apps, right? That's how it's currently working in most large companies. So you have two separate set of group, because I may not need 100 data scientists. I may need only 5 data scientists, but I might need 100 software engineers who will use those models and create Java or Python applications, right? So there are two separate aspects of the AI in terms of your skills and as you evolve and grow. So how is AI evolving? So we are still in a very narrow to broad range of AI, right? So we have things like Siri and Google. You ask some questions, it says it's still a very trained, learned model. So it's funny, as I talk, my Google was turning on my phone. So this is the problem with the phones, right? Anyway, so where we are going is the man-machine teaming part is currently where we are going. We are very far away from general AI. I mean, there is no way. There is, yeah, people are worried. I know people like Elon Musk and many people are worried that there will be singularity. What happens if machines takes over? I mean, it's a many years, probably 2050 and beyond. I would say there is 50% chance that we will have broad AI next 20 years. And it will be very mature. I mean, I don't know 100%. 100% behaving like a human being is not that simple, right? For example, if I say I went to a restaurant, I ordered ice cream, and I paid 100 rupee tip. Now, from an AI standpoint, it doesn't say I ate the ice cream. So there are certain common sense things which comes when you see and hear that humans we can do, we deduce, right? The deductive reasoning algorithms. And there's a lot of research happening on reasoning. So inferencing is evolving to reasoning. So reasoning algorithms is a good field to get your PhD if you're planning to go that way. And so there's a long way to go. I mean, it's a good area and we have to hopefully use it in a responsible way. I mean, please participate, share your papers in international conferences, and so we can all collaborate and evolve and use technology in a responsible manner, right? So in terms of IBM, where my team is focusing on, where we are focusing is, we are focused on certain aspects, like how do we advance in terms of advancing AI, this mastering language, right? Perception. How do you augment models? So we created something called Model Exchange, where I can combine multiple models and augment them, create a automated ontologies, understanding scenario planning for optimal action. So it's as I mentioned, reasoning is a big part of AI. And it'll take time. It's not fully there. There is inductive reasoning, there's deductive reasoning. So, I mean, each of those fields are their own deep study in itself. So, I mean, typically, yeah, you have to get into it's a master PhD level knowledge you would need if you want to go deep into that. If you're just applying it, that's easy. Partner with a university or your professor who knows this and then start using their algorithms in your app, right? That's probably easier way to do it. Hardware is also evolving, right? People are like NVIDIA are putting more AI onto their chips, and how do you put accelerators and move things to the edge, especially with the advancement of 5G? What happens, right? In fact, I'm doing it myself within our hybrid multi-cloud. What we want to do is, as we move the workload to edge, I have a SDN gateway within my edge hardware, which can connect to a private LTE network. And that private LTE 5G network is provided by AT&T, in my case here in the US. In your case, it might be Ericsson or Nokia in India. In fact, one of my friends is the head of engineering at Motorola, and he was telling that to me like 2 days back. And so I think, and then now comes the whole ethical aspects of it. Fairness, value alignment, robustness, explainable. Is it an explainable AI? What is explainability? Yeah, these are good assignments for your professors to give to you, and you should probably think and write, and it's probably slightly depends what it means, right? These are good self-learning projects. Yeah, Project Debater is a good example. I would highly recommend that. Go take a look at that. I mean, these are some of our platforms. It's available to you. I mean, the Watson Studio is like Microsoft Visual Studio, where you create your AI application. You can ingest your data, create your AI models. I mean, take that AI model and use it in your application. I mean, that's the most common one, I would say, the Watson Studio. I mean, it's free. It's probably for 3 months. You can use it free and see how you can start creating. There's a lot of examples in there. There's code in there. I put some links where you can see if you want to create some small applications, how do you do it? It's at the end, right? And I would definitely start with Watson Studio, which is the basic thing that any student can use. In fact, most of our developers are actually students. I mean, they do a lot of creative things. And then we have to partner them with companies who might want to use that. And this is the tool how we use to understand fairness, right? Whether it's fair or unfair using attribution analysis. And let me see if I can do a quick demo while I'm here, right? Hold on. Can you see my screen? Can you see the cat? Dr. Jain?
No, sir.
You can't see my cat?
You have to just share your desktop, sir.
Again? Okay.
Yes, sir. Just share the desktop so we'll able to see, sir.
Okay, how do I do that? Stop sharing, nay.
Stop it, sir, and then again start share desktop, complete screen.
Share, and then you want to share, and I should say
full screen.
Can you see it? Okay.
Yes, sir. Yes, sir. Perfect, sir.
Okay, so I'm going to show you an example of what happens if you don't build your AI, right? You might all say, oh, I created a TensorFlow model with convolutional neural network that can automatically identify a cat. I have a camera in front of my house and I can automatically tell who's there, right? I mean, for a trained person, you can say that, or if it's unknown, you can say it's a cat or a dog or something. So now the problem with this, let us say I created a model and I want to say, what is it? Let's say I selected a cat. What is my AI saying? So AI says with 92% accuracy, it's a cat, right? That's how any AI will work. And now your professor is going to give you A grade, good job, and you're top of your class, right? Now your friend will come, hey, Utna, not so soon, my friend, and he would say, I'm going to launch some kind of attack on your AI model. Now, when you do the demo in front of your class for your thesis submission, your cat has become ambulance. Now your A grade is gone. Now your professor is saying, hey, what happened? I told you to go build a AI model that detect a cat. It has become an ambulance. Why did it happen? Now, in a classroom setting, it is fun, but in reality, if it happens, it's a major problem, right? How do you figure that out? So you have to ensure that you have to protect your models just like you do your security testing. You have to protect your models against cyber attacks, right? So cyber security is a big aspect of it. I mean, if I I can defend my attacks. Let's say I start doing some signal smoothing and feature sequencing. If I had done this during my model building, probably your friend couldn't attack your AI model, right? You're back to cat. So just wanted to show that example on how these things are evolving, right? Let me stop sharing and go back to my screen again. Share, and where am I? Okay, not that, sorry. Can you see back to my PowerPoint? Can you see that?
No, sir. You
Okay.
have just shared your desktop, sir. Please start PowerPoint. We'll able to see.
Okay. How do I do that? Stop. Share. Okay. Okay. Now I want to give another
Yes.
example of Edge AI, right? So this is the project I did with NASA last year. So NASA has something called Frontier Development Labs. We bring PhD students from around the world. So I was a mentor to a team from Cambridge and Stanford to getting ready for a Mars mission. So Mars mission is probably 2030, this long time. But here is the problem. No human being has gone to Mars. How do you create an AI model? Where is the data, right? So I had to create a synthetic data in my lab to start training these AI models. And it was ECG, EKG, things like that. So time series data. And I have posted a blog on LinkedIn. You can read my blog where the actual final presentations from that NASA project is posted. It's available to all of you. So you can check my blog on LinkedIn and you can get more details how we are using Edge AI. And I also put a link to the IBM Edge computing thing if you want to play around. That's a good one for college students to do new research because Edge AI is a big area. Simple, I want to give a quick exposure to quantum. Obviously, quantum is a new field. It's a big evolving field. But in simple terms, a traditional computer works in bits, right? Zeros and ones. You all know that, your gates, right? It's on or off, similar to electrical signals. Quantum, think of it like a coin rotating. You take a 1 rupee coin and rotate it on a table. So at any given point in time, you could have any state. It could be 1, it could be 0, it could be 1 and 0. And that's the biggest part. What does that mean? That means you can use it to solve the large NP kind of problems, right? Whether factoring, Shor's algorithm, discovering new molecules, drug discovery, right? JP Morgan Chase is working with us for portfolio management using quantum, right? How do you understand the market risks, things like that. And just an example, I mean, we all use 64-bit machines, right? A good laptop is 64 bits. And that is way lesser than 2-qubit quantum computer, right? Look at the comparison. So it's 2 power n. So if I say I have 16-bit quantum computer, that is 2 power n in terms of equivalent capacity. So if you want 100, I mean, right now, I think IBM has 50-qubit computer, and it's available on online. You can request access to IBM Q through the web application on IBM Cloud. And we make our own processors in New York. It's based on microwave and Josephson junction, the superconducting materials. And it's all obviously in a very cold place, minus 270 Kelvin or something. It's like in a dilution refrigerator where it runs. And this is a good paper you can read. I mean, I'm not getting into details of it, but yeah, as of last month, we had 18 systems running on IBM Cloud and 200,000 plus users. Most of them are university departments and university students doing research around the world. There are only 2 from US, rest are around the world. It's a global system. So you can definitely request access to IBM quantum systems and start maybe some kind of master's research project or something. Now, key part is the quantum volume, right? How it works. And so somebody says, I have 16 qubit computer, and somebody says I have 25 qubit computer. Is 25 qubit computer better than 16 qubit? Not necessarily, because the quantum volume is the metric you have to use. It depends on what you have and the error rate, right? That's the key part. Now, with that being said, I don't want to waste too much time. I would give it to my friend Srikanth, who's the CEO of Blue Eye, who will show you how he has been able to collaborate and create something very unique where his software can detect COVID from X-rays, right? With that, I will stop sharing, and Srikanth, it's all yours.
Thank you so much, Ramesh, for that. Let me quickly share out the screen. That's a wonderful presentation. Thank you again. I think it's way up to the students and the attendees level, but definitely excited to share certain key features and come back up over here. Let me know when you are able to see the screen. And yeah, absolutely. So I don't want to bore you with the presentation, but the reason I brought back, hi everyone. I'm Srikanth Kodeboyina, founder and CEO of Blue Eye Soft. So one of the quick things is that I sit on the State Board of Education and Economic Development. So being a millennial, we bring a different aspect on thinking what education is and how can we take the research and technology from universities to a real implementation system. That's where the innovation and advancements comes into picture. I would like to quickly take 10 minutes and show you a little bit of BES background and then show some of the key cool applications in a live and end up with a quick 1-minute video where you would enjoy a little bit something happening on the space. So BES is a South Carolina based company. We are an SCRA-SC launch. That is, state of South Carolina has an entity called South Carolina Research Authority. So we are one of the company which is funded and supported by SCRA. We are also an AFRL, Air Force Research Labs Catalyst Space Accelerator company. We started in 2017. And we were supported by various organizations locally, nationally, and internationally. So SCRA, as we mentioned, that's a little bit of info. So we are associated with Defense Innovation Unit. So I'm myself a space scholar, so Space Foundation. I was on trade missions to 7 different countries. And we partnered with international universities from Poland, universities from Canada, like McGill, University of Toronto, whatnot. So we had a global presence. All of our focus is on to commercializing technology, bringing something from an innovation lab to a real world practical application. So we were being supported by major large corporations like Amazon, Lockheed, and then we being an AFRL research CSA, we are a space company, and which we took a little bit quick pivot onto the healthcare, considering the COVID-19 pandemic. So we received a couple of awards like CDCA awards, Innovation Spotlight, SBDC, New Business of the Year, SBA, Minority Business Person of the Year, and we work with various large corporations. One of the goals that we really wanted to show is on how we could actually diagnose COVID with the AI models. So as I mentioned, we were on data analytics, advanced data analytics, space-based company. We really got from, I graduated from University of Dayton. Even after I personally studied at 6 different universities and 4 universities from US. So when the pandemic really started, we tried to identify how could we really see this. So one of my university professors, which I graduated a decade ago, was building a lot of AI models. So we quickly took that technology and then got exclusive rights from university and then patented that and then really started using it. So the university was conducting research on pneumonia, lung cancer, malaria, and TB. So we were able to quickly tweak that onto the COVID-related system. So initially we were figuring it out on how we can do that to the mass public. So CT scans, X-rays, imagining the pandemic, it was really, really hard. So we were able to offer on certain key areas, and we call that like software as a medical device. FDA, as per the FDA norms, we are like a class 2 medical diagnostic device. We are still in negotiation conversations with FDA. So here is a typical overview on how that actually looks in a clinical workflow. So how could a radiologist really look at an X-ray and come back with his own thoughts? How AI can actually help radiologists. Typically, they spend 15 minutes of time on a single X-ray, and we are trying to do that in seconds of time instead of it, and having, again, ethical, as you heard from the previous speaker, that, it's again, how do you really do it and what kind of data that we go on. So here is how our product really goes on. We have a cloud deployed model, on-premises, cloud API. So one of the key factors while we were actually working on came to be like rapid testing, PCR swabs. So we did a quick comparative diagnostic test. So we were on something like, we were trying to use real world application is always completely different. But we tried to do the disease progression, patient triaging, early decision making. So you would be able to see this disease progression in few minutes. So what did we do in 60 days? Why are we trying to show this all to you? So speed is the need of the moment. How could we take the university research and exactly get into a real life product? So we have done this in 65 days. March 28th is when we got that. It was a university non-functional product, but they had a 10 years of R&D behind it. So we quickly built 5 different models, got that provisionally filed, secured it. Today you will be seeing beta 1.0. 2.0 is not yet open for public. We partnered with Fortune 500 companies out there that include Amazon, Oracle, Microsoft, whatnot. One of the key pieces that we had quickly established relationships with Stanford, AMI, University of Dayton, Duke, whatnot. And we had 27 companies that are exactly walking our way. Partnered with more than 20 countries, which we got. Poland, Kuwait, UAE is really going up into a much higher level. So before I go, let me show a quick demonstration of the product and then show what our space related system we were exactly using. Before COVID, we are on the space related piece. So let me show you a quick overview on how this AI dashboard system. So here is a quick overview of tool. Typically, you can see the data analytics behind scenes, clinicians, how does that really affect on the community piece? So we have various modalities. And since this is just beta.1, which I opened out, you could only see few features. So let me select a couple of X-rays and show how this exactly work on it.
Yes, Srikanth, we cannot see your live demo. You're still on PowerPoint.
PowerPoint. Okay, let me just switch back. Thanks for sharing that. Let me stop the screen, share it back.
Yep.
Let me share my desktop. Yep, is it up there? Sorry, thanks for confirming that.
Now you're good. No, yes, go from beginning. Go back to your original application. Start from first, the demo.
Thank you. So that being said, here is a quick dashboard view of this. So typically, this is what I was talking about, the community epidemiology and clinician feedback. This is a beta.1 where you see the X-rays, CT scans, and then pneumonia or viral concepts of here. So typically what you do is that you choose an X-ray. So typically it would be a couple of images, right? So I'd show you 2-3 things. If you select an image and then hit upload, that's how you really see. And it's all what it takes. Now you see the probability of COVID like 100%. So you should be able to see a multiple disease progression is something which we are trying to show. That's all. This is how fast which you could actually detect out and say that, how could you really analyze and see the progression of COVID on a single patient? So initially we have seen it has 85.6 probability, and then it still increased to 100. Later, the patient started responding for the treatment, and then he's up in a good stage. So this is a quick high-level overview of the system. I would also wanted to share, let me know if you can see this screen. Before I end up and share this, considering the time factor, I'd give a quick 100-minute video on how we are really using advanced data analytics systems on the space. We were focusing on the impact of solar weather on satellite orbits, which you can see. I want to thank all the students and Shah College for getting us there. So we are happy to collaborate and work with students that are interested in doing some innovation or innovative products and would like to do some interns virtually, we are happy to support. So that being said, let me quickly share a 100-second video and leave some open time for Q&A. Let me know if you can't hear or something.
In 1957, the Soviets launched an orb the size of a basketball into the Earth's orbit, forever changing the trajectory of the human race.
This is a breathtaking pace, and such a pace cannot help but create new ills as it dispels old.
Today, over 3,000 such man-made devices crowd the orbit of our planet. Calculating the risks to these vehicles has become as critical as the operations they support. Although impervious to the weather conditions inside our stratosphere, bursts of radiation from a solar storm can potentially disrupt navigation systems, radio communications, or destroy vulnerable electronics. Emerging technologies from independent stakeholders offer more and better data, but have not solved the greater problem of comprehensive risk prediction or assessment of contributing environmental factors. No single technology organization has stepped up to this astronomical challenge until now. Blue Eye Soft, with its growing network of stakeholders, is setting out to do just that by fusing current and historical data from multiple technological stakeholders. Blue Eye Soft is creating a new weather map above our atmosphere. By merging AI, machine learning, predictive analytics, domain-specific algorithms, satellite component data, front-end visualizations, and interactive dashboards, Blue Eye Soft will generate actionable insights to equip those responsible for the health and future of orbiting assets. Space is the last frontier undivided by territories, owners, or governments. Only a solution that is equally universal and inclusive will represent a real solution. Blue Eye Soft is bringing that solution in sight.
So that
In 1957, the Soviets launched an orb the size of a basketball.
Sorry for that. I think, hope that really helps out there and give a little bit of insights, and we are open for questions.
Dr. Jain?
Yes, sir.
Okay.
Sir, thank you so much. It was a really wonderful presentation. Before going ahead, now I would like to invite our principal, sir, Dr. Bhavesh Patel, sir. Sir, please.
Yeah, thank you so much, Dr. Nilakshi Jain. I thank our today's speaker, Mr. Ramesh Menon, who is Chief Architect at US Federal CTO at IBM, and Mr. Srikanth, Managing Partner at Blue Eye Soft Corp in Information Technology and Services at US. This, at our college, we had started an international webinar series, and I'm very happy to see that it has begun with the different class apart speakers. Today, what they have spoken specifically on AI and how AI, new innovative way, and the research that is helping in a different area. And not only talking, they have demonstrated the actual live product, which will help the students and the faculty by and large to think in a different direction. And the feedback which I am getting now on my personal messaging, that there are many students and faculties who are actually keen and looking forward to get association and to do some development under you. As the research cell of our institution has been really powerful, and they have developed several products, and a few of them are being patented also. We have already applied for a patent. And I look forward that similar kind of research will happen with these two speakers and their companies. I specifically cannot forget to mention the name of Mr. Kirit Udeshi from the University of North America, who has been pioneer in arranging this whole series and the speakers who have been class apart, and probably it is the first of its initiative that we have taken in Mumbai colleges, specifically in engineering colleges. So I thank both the speakers and Mr. Kirit Udeshi for arranging this wonderful talk, which has thrown a light in a different direction onto the innovation on AI and how it can help in continuing and growing the large research in this pandemic time, and how it can help in development of any kind which can help in reduction of COVID-19. And also congratulate Dr. Nilakshi Jain and the research cell of our institution of having been thought and successful execution and the beginning of such webinar series, which will help lot of students as they are now available to attend these webinars at any time. I really thank you all of you on my own behalf and the institution. Thank you very much.
Thank you, sir. Um, so now we have some few questions from the audience behalf. So Ramesh sir, how do you see use of technology involved in future for business leaders?
Well, I think the digital transformation is taking off, right? As long as business models evolve and support digital business models, right? How do you leverage cloud as a core technology platform to build your business, right? All the cloud native application like Salesforce.com. I mean, everything is done on the cloud. So the evolution of digital platforms is a big part, and most existing companies, it's a digital transformation journey. For new companies, I mean, one of your students wants to go do a startup, it's a lot easier. I mean, that's easy. So I would say the evolution of digital platforms and the new business models. Start thinking how all these technologies can help and change the way you're doing in a new way. In your university, how do you create virtual research teams? How can we do that in a better way, right? So there's very creative ways. I would definitely say the digitization of business is a big trend, and that's one way I would highly recommend people to look at that.
Thank you, sir. So one question my students wants to ask you, Srikanth sir, that as a student, how you thought that you will start your own company, that too with the AI based company? Have you ever thought when you were a student?
I studied entrepreneurship. That's a great question. Thanks for asking that. That's bringing the millennial perspective on it. So I studied entrepreneurship. I was a student just like many of the students there, came to US to get a master degree in engineering, but focused on entrepreneurship, and then worked for Fortune 100 companies over here. And then we were trying to figure out what is the next best thing. That's how we really identified the space. We wanted to do innovative solutions, right? When you come from India to US, so that's what all my focus was. And by time, I was never focusing on COVID. So it was more onto the space, which looked so cool, trying to support Space Force. Now, whoever our Air Force team became the Space Force. And then we just wanted to focus on how we can better the community. And that's how the COVID piece came into picture. But whole power came to the scene when you can collaborate and associate with universities. And how quickly can you bring in university technology into the market? Commercialization of product is key. And if you start thinking in that direction, I think that would help students to work in a different style. Now the students' way of thinking is completely different, and this could be a good example.
Yes, sir. Thank you.
I want to add something to what Srikanth mentioned, right? So as university research, you probably need to group your research into 3 buckets: early stage research, maybe mid stage research, and advanced research. Advanced research is typically TRL level 7 or above. TRL is technology readiness level, and TRL 9 is a commercial product. So if you can tell your students that, hey, these are all the research happening, and somebody who is not even associated with that research can take that technology and go and do a startup. So universities also has to help the students. How can you help? Like that's what Srikanth had, right? UDRI, University of Dayton, gave him an IP, and he created a company out of that IP.
And they did that with 2 days.
Yeah.
It's 2 days, 2.5 days, a multi-million-dollar deal. You call in the morning, 2 days you happen it. And that was the pace within almost every university, name it on the globe.
Correct.
So how agile you are. Yeah. Mm-hmm.
Thank you. Thank you, Ramesh sir. Thank you, Srikanth sir, for an enlightening and entertaining presentation on the right way to introduce AI and applied research. We appreciate having this fascinating area called as, AI and the applied research. On behalf of SHA and Anchor Kutchi Engineering College, I have a small token of appreciation here for our speakers. Please accept it with our sincere thanks. Thank you so much, Ramesh sir. Thank you so much, Srikanth sir. Now, here, a special vote of thanks. Being here is Mr. Ramesh sir, and the person who made it happen is Mr. Kirit Udeshi sir. from University of North America. We really appreciate your effort and thank you, Kirit sir, and the team from University of North America. I request Kirit sir if you would like to share something here. Kirit sir?
Sure, definitely.
Yeah.
University of North America is very, very proud to be working and along with the Shine Anchor Kachi Engineering College. We have signed the MOU. We have to do the exchange of students and faculty and researchers and all that. We were really looking forward for this year to do that. However, due to the COVID, I know we have to put it off, but at least I'm glad that Anshwed and Nilakshi ma'am, both of you guys worked with us to do this international webinar series. And I definitely want to thank Ramesh, who is in the West Coast. He started the seminar at 6 a.m. his time. Srikanth, you and I are on East Coast, so for us it was 9 a.m. Much better timing. But Ramesh, I really thank you for that. It's really wonderful that you joined at this early time and greatly appreciate, because with your Virginia address, I got confused that you are in Virginia. So
No, you're fine. I mean, my lab and team is in DC, so I do have a team and lab in DC, but I'm in West Coast, so I'm all over the country. Let me put it that way.
Wonderful. So next time you both are in town, we have to have lunch together. So we'll definitely do that. And I'm hoping that this COVID crisis gets over soon so that we all can travel, as well as the kind of faculty and students from Shine Anchor can come and visit our college in University of North America here in Washington, D.C. area, and we can have more and more collaboration together. So I'm really glad that this is an excellent initiative by Nilakshi ma'am. You have taken a great effort in that, and we are glad to be partnering in this and looking forward for this other webinars we have in rest of this week, as well as we are hoping we'll have more webinars next week. But thank you very much, and thank you, Ramesh and Srikanth again.
Thank you.
Thank you, everyone. Thank you, Dr. Jain, Dr. Patel, Mr. Udeshi, and thank you, Srikanth. I just called him yesterday and told, hey, Srikanth, can you join me? Right? He was quick to jump in. Thank you very much, as always.
Thank you, each and every one of your best present here today. I would like to thank the webinar coordinators, Ms. Shwetambari, Radhika, and Bhushan sir, and complete research team and my student team, Ritik and Ansh as an co-host, and all the working members who made this webinar possible. So also, lovely audience, thank you. Looking forward to meet you all in the next webinar scheduled, as a webinar scheduled are in your screen only. So do register in collaboration with the University of North America. We have other webinars scheduled 5:30 p.m. and 6:30 p.m. And tomorrow we have webinar by Dr. Dhananjay Kalbande, AI in Healthcare. Then by Mr. Kasam, and then Mr. Glenn Gracia, again with the University of North America. So all please fill the feedback form. So participant, you will receive the e-certificate on your mailbox. Thank you so much, speakers. It's really a wonderful and the knowledgeable webinar. And looking forward for the collaboration as a research coordinator. It's a great news and a great outcome to host the webinar. Thank you, sir.
Thank you all. Stay safe. Bye.
Thank you. Participants, please fill the feedback form so that you can receive the certificate in your mailbox.